Welcome back to Daily Dose of Space. For most of human history, planets were simple, rocky worlds close to their stars, gas giants farther out, cold, quiet, predictable systems that followed clear rules. And then we started finding planets around other stars. What we discovered didn't just expand our understanding of the universe, it shattered it. Because many of these worlds should not exist at all. They are too hot, too dense, too close to their stars, or too massive for any current model of planetary formation to fully explain. Some orbit stars that should have destroyed them long ago. Others defy physics in ways we are still trying to understand. Today, we are not talking about science fiction. We're talking about real planets, confirmed by observation, that exist right now in our galaxy. And the deeper we look, the stranger these worlds become. Worlds that should have fallen into their stars. One of the first surprises came from planets that orbit dangerously close to their stars. These are known as hot Jupiters. They are gas giants, similar in mass to Jupiter, yet they orbit closer to their stars than Mercury does to the Sun. In some cases, a full orbit takes only a few days. The temperatures are extreme, often exceeding 2,000 degrees Celsius. According to older theories, planets like this could not form so close to a star. There simply wouldn't be enough material, and the intense radiation should blow away gas before a giant planet could grow. Yet, they exist, which suggests they formed farther out and migrated inward, somehow surviving a violent journey through their planetary systems. But even that explanation struggles in extreme cases. Some of these planets are so close that their atmospheres are actively evaporating into space, forming long, comet-like tails of gas. We are watching entire worlds slowly being stripped away by their stars, and somehow they remain intact. This raises a disturbing question. If planets can survive conditions this hostile, what does that say about the limits of planetary stability? And how many more extreme worlds are we still missing? Planets made of impossible materials. As detection methods improved, scientists began finding planets that made no sense chemically. Take so-called super-Earths. These are planets larger than Earth, but smaller than Neptune, a category that doesn't exist in our solar system at all. Some of them are incredibly dense, suggesting compositions rich in iron or exotic high-pressure materials we barely understand. One planet appears to be almost twice as dense as Earth, compressed under gravity so intense that familiar rock structures may not even exist anymore. At these pressures, matter behaves in ways we cannot reproduce in laboratories. Other planets seem to blur the line between gas and solid entirely, with thick atmospheres transitioning into supercritical fluids rather than clear surfaces. And then there are worlds that may be dominated by carbon. In theory, a planet forming in a carbon-rich environment could have landscapes made of graphite, diamond layers kilometers thick, and chemistry fundamentally different from anything we know. These are not fantasy ideas. They are logical outcomes of real astrophysical conditions. And yet, we have no idea what standing on such a world would even mean. Because physics, at these extremes, stops behaving intuitively. Planets in places they do not belong. Some of the strangest planets are strange, not because of what they are, but where they are. Planets orbiting dead stars. There are confirmed planets around white dwarfs, the dense remnants of stars that have already destroyed their interplanetary systems. For a planet to exist there, it must either survive an incredibly violent stellar death or form afterward from the debris. Both scenarios are difficult to explain. Then there are rogue planets. These worlds wander through interstellar space without any star at all. They are cold, dark, and incredibly numerous, possibly outnumbering stars in the Milky Way. Some may have thick atmospheres or internal heat sources, meaning they could remain warm despite drifting through cosmic darkness for billions of years. Entire planetary systems could exist without sunlight, and perhaps most unsettling of all are planets orbiting pulsars. Pulsars are rapidly spinning neutron stars that emit intense radiation capable of sterilizing entire regions of space. Yet planets have been found orbiting them with clock-like precision, which means these planets either survived a supernova explosion or formed from its aftermath. Both possibilities are terrifying. What these planets are telling us about the universe. Extreme planets are not just curiosities, they are warnings. They tell us that the neat, orderly picture of planetary systems we built from our own solar system is incomplete. Possibly misleading. The universe is not optimized for comfort, habitability, or familiarity. It is optimized for diversity, for chaos, for outcomes that push physical laws to their limits. Every extreme planet forces us to rewrite formation models, rethink atmospheric physics, and question assumptions we once thought were universal truths. And here is the most important part. These planets are not rare exceptions, they are common, which means the universe is far stranger than we ever expected, and Earth may be a very specific solution to a very narrow set of conditions. The more planets we discover, the clearer it becomes. The universe does not care what we expect to find. So when we ask whether Earth is special, the answer becomes complicated, not because life is common, but because planets themselves are wildly unpredictable. And this leads to a final thought. If planets can exist in conditions this extreme, what kind of worlds are still hiding beyond our detection limits? And what would they tell us about how the universe really works?